Hi, in this video we'll be going through the basics of debugging. This is where we can dive in and learn some actual strategies for debugging our programs and devices. Debugging is a process we use to fix bugs or problems that find their way into our programs as we develop them. If you've programmed before, you've likely heard the term debugging. This is because no matter how advanced a programmer you are, it is inevitable that bugs or problems will end up in your code at some point. Debugging is the process of fixing these problems so that your program functions as it should. We call these issues bugs because in 1946, an actual moth got stuck in a relay machine and was causing it to function incorrectly. We now use this term to refer to any problems or issues that exist in a program that causes it to malfunction. The debugging process starts when something is broken or isn't working as intended. We create a hypothesis about what is wrong and why. Then we try to fix it. If we make the fix and our program now works, then we're done. But if we try to fix the program and it's still broken, we return to step 2 and try again. Oftentimes when we're debugging, it can feel a lot like Where's Waldo, where we're looking for this small detail, this one thing that's out of place in this large program. We're going to learn some strategies to help us simplify this landscape and really narrow in on where the problem might be occurring so we can actually isolate that bug. So we can isolate where Waldo is in our program. You may already know some tips for debugging programs, but let's quickly go through a few options. The first thing that helps make debugging easier is writing readable code from the start. This includes adding informative comments, using explanatory variable names, and modularizing your program or breaking it down into smaller parts. Looking through example programs and using documentation and resources is also a great way to navigate through issues in your programs. Compare the syntax and use of certain commands or structures in a program that you know works to help you find out why yours isn't. On CodeHS, you can find the documentation in the Docs tab in the editor. Most programs we develop will perform multiple actions. Using comments to section out your code and only run through it bit by bit will help to isolate the problem, which will make it much easier to fix. With the addition of physical circuits, debugging programs can get more complicated. Let's look at a few ways we can debug our physical circuits. We can revisit our debugging process to see how things change when we introduce physical circuits. With physical components, we actually need to complete this process twice. We start by writing our program using the circuit simulator to test its functionality. If we notice an issue, we debug our program at this stage. Once our program works as intended on the simulator, we build it out using our physical components. When we run the program on our physical device, a whole new set of issues can arise, so we may need to debug at this point as well. The first debugging process will happen in the MakeCode editor with the microbit simulator. The second debugging process will happen once the program is uploaded to the physical device. Debugging physical circuits can get complicated. Let's take a look at a few strategies you can use. First, double-check all your connections. If you were given an image or step-by-step directions to follow, revisit this resource to make sure connections are where they should be. Also, make sure that the metal tip of one wire is not touching the metal part of another if they shouldn't be connected. Then check all the ground and power connections. Are all the wires that are connected to ground correct? What about those connected to power? If possible, it can help with organization if every wire connected to power is red and all wires connected to ground are black. Next, check all the connections to the pins on your microbit. Make sure these connections are in the right place and then double check that the pin numbers in your program match those connected physically. When using specific components, there are some tips to help secure connections as well. LEDs only work in one direction, and it's very easy to mix up the placement of the long and short legs. If you're unsure, switch the placement of the legs to see if that fixes the issue. Resistors are very fragile and have long, flexible legs. This can sometimes make them difficult to work with. Double check that the metal portion of the resistor is securely connected to the wire it should attach to. If you're using a sensor that is not integrated into the microbit, double check their connections, as many of them have multiple pins that must be connected in a specific way. If all else fails, a good way to check if you have a faulty device is to replace the one you're using with another. Let's dive in and start debugging.